Howdy, mathletes. Today I'm going to answer the question, what's the deal with radians? Well, let's start with a wild conclusion and work our way backwards from there because, well, we have the power to do that. So this is our conclusion. We're going to answer the question, how many radians are there in the circle? And the answer is there are 6.283, approximately 6.283 radians in a circle. Okay, that's kind of a strange number. How did we arrive at that? Well, there's a few things we know about circles. How many degrees? 360. We'll keep that in mind for later. What's our circumference? 2 pi r. And what's the area? Pi r squared. Which one are we going to work with? Well, let's take a look at the circumference for a second. So we know 2 pi r. And what's something we've been working with lately? This thing, right? The unit circle. What's the radius of the unit circle? It's 1. So let's just make the radius here equal to 1. And our circumference would just become 2 pi. Plug that into our calculator. Let's see what we get. Pi times 2. Hey, that looks familiar. 6.283. Well, that's what we started with, right? So there's 6.283 radians in a unit circle, and the circumference is 6.283. Well, they're kind of connected. We kind of keep them together. Another thing that we looked at was the radius, right? Or the degrees, 360. Okay, so there's 2 radians, 2 pi radians, and 360 degrees in a unit circle. Now let's look at our unit circle. So here we have 0 degrees, and remember this is our radian measure, right? 0. Rotate up to 30, now we have pi over 6. If we rotate up to 45, now we have pi over 4. What happens if we double 45? We go from pi over 4 to pi over 2. We see how they're kind of connected? Well, they're actually in proportion. So let's just do one of those proportions real quick. Let's say 300 degrees this time. So you have 300 degrees out of 360 degrees in the circle. And I know it's here, but we're going to solve for it. We have x out of 2 pi radians in the whole unit circle. So let's cross multiply as we do. Get 600 pi when we cross this. 300 times 2 is 600 pi equals 360 degrees times x. Let's divide. Let's reduce. How many times does 60 go into that? Well, that's 10. How many times does 60 go into that? That's 6. So we have 10 over 6 pi equals x. If we reduce again, ignore my watermark, dividing by 2, we get 5 over 3 pi. And look, that checks out. So now we know that the degrees of the circle and the radians are in proportion. No matter how much we rotate in any circle, we'll be at the same kind of deal of a radian. So let's look at how that works. Well, let's pull it up. I have that off to the side. Okay, I suppose I can't open it, but let's bring the animation over from the other window. Let's hit play. Okay, so we'll go around 1 radian, and which is 1 radius, and it kind of applies to the circle and to be 1 radian of the same amount of degrees. So the length of the radian is equal to the actual length of the radius if we were to measure them equally. Finally, I have a little applet to show you. This was made by another person in GeoGebra. As we rotate around the circle, well, we see the radians up here, And we also see that, look, 1 radian here. As you go past 2, it shows another radian here, and so on and so forth. We see the arc length is 1, which is the same as the radius, and it's 6.26. It's a little off. It's hard to get it exactly to be right on the dot. And if we wanted to trace back to here, we could do that proportion one more time just to check how many degrees that is. So that would be 4.45 out of 6.283. And of course, we're approximating. Again, this is approximate up here too, because he's truncated at just 2 decimals, equals x out of 360. Cross multiply, 4.45 times 360 over 6.283. Cross multiply and divide them one step, if you don't mind me doing so. I'll whip the calculator and we'll solve for that. 4.45 times 360 divided by 6.283. And that's about 256 degrees. Looks good to me. All right, I hope that clears things up about how the radian corresponds to the circle itself. Have a great day.